So in today's video, we're going to go ahead and start delving into the notion of implicit differentiation. And so implicit differentiation is kind of when you're just differentiating functions that are implicitly written as functions of x. And so I'm going to actually do an example to kind of illustrate what I mean by that, because that kind of sounds a bit odd. So let's go ahead and see what I mean. So here we have x squared plus y squared equals to 1, and you may recognize this as the equation of the unit circle, which I've graphed over here for no particular reason. It's actually really not going to help us very much with implicit differentiation, but I put it there for fun. And so we have y kind of written as an implicit function of x, right? Because we have an expression containing x and y, and although it's not explicitly written as, y equals f of x, we do have y contained in an expression with x, and we can, as a result, treat y as like an implicit function of x. And so we're going to actually go ahead and try to determine what the derivative with respect to x, or the derivative of y with respect to x is. We're going to try to find an expression for the derivative of y with respect to x. And in order to do that, we're obviously going to need to use the chain rule over here, and we'll see why in a moment. And so let's go ahead and actually try to figure this out. So what I would like to do, it's very helpful to actually get dy by dx, is just differentiate both sides with respect to x. And so we'll get that the derivative with respect to x of x squared plus y squared is equal to the derivative of 1. We know that 1 is just a constant, so this will be equal to 0, right? We just took the derivative of both sides. And then, of course, we can go ahead and split this into two separate derivatives. So we'll have the derivative with respect to x of x squared plus the derivative with respect to x of y squared, and that's just equal to 0. And then we can go ahead and just simplify this one over here. The derivative of x squared is just going to be 2x. This just comes straight from the power rule. And then here we have the derivative with respect to x of y squared. It may be helpful to write y as some function. We can say that y equals to g of x, because why not? And let's suppose that f of x equals to x squared. Then what would f of y be? Well, f of y would just be equal to g of x squared. And we know how to kind of take care of this derivative, right? We just need to use the chain rule as it is written over here. And so if we rewrite this as, plus the derivative with respect to x, and then I'm going to put in parentheses of g of x squared, and that's equal to 0, then we can just go ahead and use the chain rule over here, because our outer function is this x squared, because we're kind of squaring this. We're squaring whatever our input is, and our input is just the inner function, which is y, which is equal to g of x. And so let me actually go ahead and use the chain rule over here to differentiate this. So we'll get 2x plus, what is the derivative with respect to x of x squared? Well, we know that that's just going to be 2x, but this time we're going to actually take the derivative of x squared, and we're going to actually input y into that, or we're going to input g of x into that. So we know that f prime of x, or actually rather f prime of y, I might as well say, is going to be 2 times y, right, times the derivative of y with respect to x, right? Because here we're essentially just using the chain rule over here. We're taking the derivative of our outer function and then inputting g of x in. So the derivative of x squared is 2x, and then we're kind of just taking, our input, which is y, which is equal to g of x, and we're kind of inputting that into the derivative of f. And then we're just going to multiply that by dy by dx, because that is what the chain rule essentially tells us to do. And so if we were to rewrite this over here, we're going to take the derivative of the outer function and then input our inner function. So 2 times y is going to be the derivative of outer function, so that will be f prime of g of x, if you will. And then we're going to multiply that by g prime of x. And another way to write g prime of x is just dy by dx, right? And this is equal to 0. So essentially all that we did here is we just used the chain rule. We kind of took our function y, right? And we input that into an outer function, and our outer function was x squared, and then we just used the chain rule in order to determine, an expression for the derivative with respect to x of g of x squared. And so then now, all that we need to do is just solve for dy by dx, because then we'll have an expression for our derivative. And so we can go ahead and subtract 2x from both sides, so we'll get 2y times dy by dx equals to negative 2x. We can go ahead and divide both sides by 2, and then we can go ahead and divide both sides by y, and we'll end up with dy by dx equals to negative x over y. and that right over there would be our final answer. And so, as you can see, we actually have this expressed as an implicit function as well, because we have an expression containing both x and y as our derivative. So essentially, I mean, I really hope this isn't too confusing because it can be a bit odd at first, but essentially all you have to do is you have to think of y as a function of x. It may be very helpful to rewrite y as g of x, as we did over here, in order to kind of remind yourself that you need to use the chain rule in order to differentiate, or in order to actually go through with implicit differentiation.